Good. Correct answer is. Okay, here we go. Correct answer is A. Here's my guess of how you answered that, and I'm going to give you an alternative way. So, negatively test charge, that's going to be attracted to the positive. It's going to be repelled by the negative. The resultant vector, cut and paste, head to tail. Good with that. Okay, so that's the electric force. Now, here is an alternative way to do it. First factoid, the electric field at a point is tangent to the electric field lines. I think I threw this out yesterday, right at the end. Okay, so at this location, electric field would be going this way. At this location, electric field would be going that way. At this location, the electric field would be going that way. Everybody okay with that? The direction of electric field at a certain point. And that's what I was trying to get you to do on the worksheet on number 6, was just pick points that would be tangent to that. Okay.
I'll remember that.
Okay. So, that's a factoid. Here's the thing that I want to bring out. If you have a positive test charge, like a scout, in or experiencing the electric field, then the force is acting in the same direction as the electric field. Okay. If you have a negative test charge, then the force is in the opposite direction of the electric field. Okay. So the electric field at this location is going which way? Electric field at that location is going which way? Show me. Point. The electric field at this location is going tangent to that. It's going that way. The electric field. Okay. If this was a positive, if there was a positive peanut, a positive point charge, we drop that in there, you would experience a force that's in the same direction as the electric field. If we dropped in a negative test charge, a negative charge peanut, you would experience a force going in the opposite way of the electric field. Okay with that? So here, we have the same conversation just at this line. The electric field is going that way, electric force in the opposite direction of that. Good? Questions there? So, a capacitor is an electronic device. In introductory physics classes, they like capacitors a lot because they create a constant electric field in between them. That's the only reason why we like them. This enables us not to use calculus. Life's good, we're just stuck with algebra. So if you take another physics class like in college or something, this is a playground that they like. Don't be thrown off on that. All they're doing is setting the stage to have a constant electric field. Okay, so give that question a shot. Tell your neighbor. Correct answer is bees, beautiful butterflies. Okay. Electric field lines go out of positive into negative. Good? Out of positive into negative. Next question. Tell your neighbor. Correct answer is A. All right. So you could answer this two different ways. One way is recognize that's positively charged and this is negatively charged, and an electron is going to be attracted to the positive or repelled by the negative. Or you could say, oh, check it out, electric field's going down, it's a negatively charged object in the electric field, therefore it experiences a force in the opposite direction of the electric field. Okay? So this brings us to number 5 on the worksheet. So you have this negatively charged, test charge, peanut, whatever it was, okay, and it's levitating. So you know that something has to be counteracting force of gravity is going to be electric force. So the sum of the forces in the y direction are equal to 0. You have electric force minus force of gravity is equal to 0. So you know that electric force is going to be equal to the force of gravity, which is equal to mass times 9.8. Okay with that? And that was mass times 9.8 gave you like 0.118 something newtons. Okay. You were asked to find the strength of the electric field. This is the thing experiencing or in the electric field. So that's why we're going to use this equation. And so you had 0.118 newtons over whatever the test charge was. And you got that. Okay. So this being a negatively charged object, meaning this has to be negative as well. We didn't have the top plate. This surface needs to be negative to repel it, meaning it has electric field lines going into it. In this case, down. How are we doing on that? That's number 5. Neighbor?
Yeah. Oh, that's a trick question.
Correct answer is? Correct answer is C. Positively charged is going to be forced in the same direction as electric field. This is one of the reasons why we like electric fields. Let's pretend that there was a curtain that separated this. You couldn't see behind the curtain. Okay? We would take our scout, our test charge, and we would test how much force there would be at different locations, and we could map out the field at these different locations. We'd have an electric field. We wouldn't even necessarily need to know what caused the electric field. There could be multiple Van der Graaf generators behind this curtain. What we know is from our test charge, how much force is it acting. We don't necessarily need to know what caused the field. Does that make sense? And so once we have that mapped out, we know the electric field, we could say, okay, if we take something else with charge and we stick it here, I don't even have to stick there. I just know, because I know the field, how much force this strip would experience because it's in the field. That makes sense? Regardless of what's causing it. Okay? So in this question here, we don't know what caused the electric field. We just know there was an electric field, and we stick something in there, we'll know which way it's being forced and how much it's being forced, like how strong the force is going to be. Okay, so Last one. Tell your neighbor. Correct answer is? Correct answer is B. It experiences a constant electric field, so it'll experience a force, constant force. Constant force causes constant acceleration. Good? Yeah. All right. We're gonna.
What if it was just a pump that was letting
Okay. While that's loading up. Okay, here's a quick demonstration. Tell your neighbor why. Tell your neighbor why. Correct answer. Tell me why they lift off. Big silver ball had a lot of cuties. Did some weightlifting. What was going on? Hopefully your conversation sounded a little something like this. Electrons are going into the conductive pitons because they're aluminum and they're metal. Electrons don't like each other and they repel each other to the point where you can lift the piton. Yeah? Yeah, totally. Why did it only go one at a time? Okay, charge definitely goes to the outside, but it could only lift up what was equal to the weight. One at a time requires a lot less force than a whole stack. Okay? All right. Here was number 6. Number 6. Something like that. Okay, so Okay, so this is the point that I was trying to, at the different locations, see how it's tangent to the electric field lines. Okay, and then somewhere in the middle, this guy's creating a field going outward, so at this location where the heart was, it's going to the right. This negatively charged is creating electric fields going inward. At the heart is also going to the right. And that is why you added them and not subtracted them. They're both going in the same direction. Cool with that? That was that. All right. All right, you got a pre-quiz due tomorrow. Okay, all right. So just letting you know, you are being recorded. Whoever wants to get on this. So you're gonna stand on styrofoam so long as your hand is connected to the ball, no discomfort. Okay? I'll give you this metal rod. You'll hold it by your foot until I tell you to do something different. When I tell you, okay, go ahead and touch something metal, you're going to touch that, this, that, any of those. Okay? And then you can take your hand off and you can step down. No discomfort. The operative adjective is weird. Okay? I'm on it, if you would like. This is like...
Wait, so if they take their hand off the ball, will there be discomfort?
Bryce, you gotta get up here and take your hand off the ball, man.
Why am I cross math getting called?
Dude, you gotta get up there and take that. Take your hand off and see if it hurts.
Get up there.
My legs are cramping.
Oh, kids, this is like...
You never know.
This is like the fun part.
Oh, come on. No.
Like, will it hurt? Will you feel it then?
I won't feel it, no. What does it feel like?
Feels like my hair's standing straight up.
Yeah. Check, look at, you see yourself?
Yeah,
Yeah?
it is.
Yeah. Okay, go ahead and touch the... Yep, you're good.
Alright.
Does that hurt?
No?
Any discomfort?
Just kind of felt weird.
Weird. See? That's the way I describe it. Next.
It was weird.
Somebody needs to take their hand off.
Come on. This is like,
I'm not going to do it.
why would you not? This is like, how often do you get to touch a big electric ball thing?
I don't like this.
Oh,
No, Adam's gospel.
yeah, that's
I'm just
Touch it?
yeah. Okay, as the rod's gonna touch the metal, what's the sound? What do you think that is? Electron
I just hit the ball.
jumping. Next.
Like he's
Good.
Yeah, Gil, after this turn, you keep the hand off the ball.
Oh, wait, no, this is good. Yeah. Yeah, I know, I feel like that's pretty cool.
It'll
Will
be
you
like
take
the
the
one
hand
like
off?
No.
No.
Yeah.
Put it on.
How do you like push everywhere?
See your hair slightly. Okay. Now watch her hair as she touches the metal. Okay. Good stuff. Thank you. Next.
Oh, I gotta see how you're right.
Yeah, I'm just.
No!
I have plenty of time.
You're not sliding.
It's not
I don't really even know.
It's like, it's.
No way. I can't believe this. You guys are like.
I know all this. I know.
Do it, Myron.
I'll do it if you do.
Yeah, Lucy, do it.
She just did it.
What is she talking to me? Okay.
Okay. Why do you think hair stands up like that? Why did the flaps on an electroscope? What happened when these got charged? What happened when those got charged? What happened? These got charged. Spread out. That's exactly what's happening. Okay, go ahead and touch the metal. Nice.
It's showing my breakage now.
Anybody else?
They know. It's gonna get
Yeah.
busy and
It's like actually like. It just felt like it was just hair.
Yep.
Haley.
Actually, hold on. Yeah, touch the metal. See it?
Alright, it's got time.
You?
Make my way out. Time to go.
Anybody else? Look. Focus your attention. Stuff. Anybody else?